Let's talk about preparing solutions in the lab. Let's say if you want to make a solution in the lab, obviously one of the things you want is you want a particular concentration. You want to decide beforehand what concentration you want, and you also want to decide how much of the solute you're going to use, or how much of the solvent you're going to use, or how much solution you want. Okay, so remember when we define concentration, you have amount of solute or solvent in the numerator over the total or the solvent in the denominator, right? So if you know what concentration you want, you have to decide on one of these other two, and then you can figure out the other one. So you use the defining equation to calculate. So you either decide on the value for the numerator or the denominator, and then you figure out the other one. So you use the defining equation to calculate the other one. And then once you have the values for the numerator and the denominator, then all you have to do is convert those to measurable lab quantities, typically grams if you're dealing with solids. If you're dealing with a liquid, it's not a good idea to weigh liquids, so it's best to look up the density of the liquid and convert the grams that you need to milliliters, okay? And use what's called TD glassware. You have glassware that's labeled TD. TD stands for to deliver. So those are glassware that are specifically calibrated for dispensing precise volumes of liquids. Now, if your desired concentration is of type 1, remember type 1, your denominator would be volume of solution. What you would have to do is put your solute in a piece of glassware that's marked TC. TC means to contain. An example of that is a volumetric flask. So you put however much solute you need there, and then just bring it up to the mark. Add enough water to, if you're doing an aqueous solution, to get to the correct total volume. Okay? Don't make the mistake of just adding up volumes, because volumes generally, like if you're dealing with liquids in particular, they don't usually just add up to your desired volume. You have to use a piece of glassware that will actually tell you how much total volume you have. Just to illustrate, let me show you the volume, a volumetric flask. This is an example of a piece of glassware. So let's look at images of volumetric flasks. There's plenty of those on the internet. Okay, so it comes in different sizes. You'll notice these flasks have a marking right here. That's called a fiducial mark. So these are designed to contain. So if you look at the label here, you'll see a TC on the label. This one in particular, for example, will hold, if you bring it up to this mark, you'll know that you have a total volume of 1,000 mils. This one in particular will bring it up to 500 mils, and so on. Okay? So that's TC, to contain. An example of a piece of glassware that's intended to deliver would be a pipette. So a pipette, let's look for images of pipettes. Okay. Oops. These are pipettes, and so they come in different sizes, so you have to fill them to that marks. For this particular type of pipette, it's designed to deliver a particular volume, or you can use a graduated cylinder also. Okay, you may also use what's called a burette. Okay, this one, these are some calibrated pipettes right here, so there are markings there that allow you to control how much volume you want to dispense. Okay, and a burette is also something that you could use to deliver liquid. So these are burettes, examples of burettes. Okay, and so this stopcock right here, when you turn this on, when you turn this 90 degrees, this right now is on right now. If you turn this 90 degrees, it shuts off the liquid. So the way this is set up is, if you have a liquid in here and this is open, the liquid will flow out. So you read the level of the liquid in the burette before and after you've dispensed your liquid. So for example, if your liquid level starts out at 22 and ends up at 24, that means you've delivered 2 milliliters. Okay? So Let's look at an example here. Let's say you want to prepare 500 milliliters of 0.5 molar sodium chloride. So what's our desired concentration? 0.5 molar, right? So we've decided we want 500 mils, so that's the denominator in the defining equation. Remember, molarity is moles over volume, right? So number of moles is the numerator, volume in the denominator. So we decided we want 500 mils, so that's 0.5000 liters. So what's our numerator? We multiply molarity times volume. So 0.5 times 0.5, that should give you, okay, 0.500 moles per liter times 0.5000 liters. Okay, so that gives you 0.25. 3 sig figs, 0.250 moles. Okay, that's the moles of solid. Well, there isn't a thing in the lab that tells you how many moles you have. We don't have a mole meter, so you have to convert it to something you can measure in the lab, and that would be grams. So you had 0.25 moles of sodium chloride. You have to change that to grams. So 0.250 moles sodium chloride. You're going to need the molar mass. A mole of sodium chloride weighs 58.44 grams. That's the molar mass. Oops, wrong conversion. 58.44 grams for 1 mole. So moles cancel out. That gives you how much? A quarter of 58.44. 14.61 grams. Okay? Okay, 3 sig figs, so I only need 14.6 grams. So, what do? I go to the balance, I weigh out 14.6 grams, okay? And I put it in a volumetric flask, so I'm going to transfer 14.6 grams of sodium chloride. So it's going to be, I'm going to have a salt here. And then I'm going to add enough water, okay? So I'm going to add enough water to make it 500 mils. So I'm going to use a volumetric flask that has a 500 mil capacity. If I bring up my solution, my water level there to that mark, I know that I have a total volume of 500 mils. Okay, so grams of solute here is 14.6 grams. Amount of solvent here, it's not 500 mils of water. It's enough to bring the total volume to 500 mils. All right.